All right, you guys, we're going to talk about mass wasting. And mass wasting is the downslope movement of loose material on hillsides. Okay, so if you think you're thinking landslides or something, landslides are one form of mass wasting, but there are a lot of other forms of mass wasting. Okay, the picture you're looking at is in Hong Kong, and Hong Kong has a large population, a small land area, and so they actually, build a lot of buildings, kind of in unsafe areas. And so, what I hope to do in this lecture is teach you about mass wasting, but also make sure that you don't buy a house in an area that's really not very wise. And there's a lot of stuff in this picture that tells me that that's really not a good area to build. Got a steep slope behind you with a lot of vertical elevation. You got loose material, and all you need is a good rainstorm to make that loose material move down slope, or a shake, or an earthquake or something. So we'll make sure that you don't make that mistake. All right, so it's downslope movement of loose material like soil, rocks, etc. that are found along the sides of a hill. You do have to have a hill to have this because the driving force of mass wasting is gravity. Now I know a lot of people would say, oh, it's water. You can actually have mass wasting with no water. Water can make it worse, but you have to have a slope and you have to have gravity acting on it. And then, if water comes in secondarily, but gravity is definitely the driving force. Okay, so if you do have an unstable slope, it's just a matter of time before that material moves down slope. And it's especially problematic in areas of high relief. And what that means is, like in the previous picture, that wasn't just like a 5-foot cliff behind those buildings. That was a 1,000-foot cliff behind those buildings. And your chances are much greater. Plus, you get that momentum, and it can move out very far from that hillside and kill a lot of people. All right, during the course of this lecture, we'll talk about landslides, true landslides. We'll talk about different forms of debris flows. We'll talk about soil creep, and we'll talk about rock falls, like what's been happening in Yosemite every couple of years. This lecture really needs a lot of videos, and so make sure you go into the folder and watch all those videos, because the videos really let you know how these different types of mass wasting move in different ways. So it's mass wasting is all driven by gravity. The driving force is gravity, but things that can trigger it, earthquakes. Every time there's a very large earthquake, there are landslides and mass wasting events triggered by that. Okay, and pretty much every time there's a heavy rain, driving home on Highway 80 after the heavy rains that we've been having, I noticed a few little mud flows. They have what are they called? The orange cones along the sides of Highway 80, where the little mud flows are coming kind of down onto the sides of the highway. So, after every heavy rain, we're going to have some sort of mass wasting event. Okay, and mass wasting events are dangerous and costly. Now, when I make a video, when I do these, I write down kind of, okay, what do I have to make that little short extra video for to put in your folders? And I don't really like this diagram here. I have a better kind of way of explaining whether something's going to stay on the hillside or move down slope. And it always brings me back to my favorite physics lab experiment, where we walk in and there's bricks and there's, what are they, 2x6s and things like that. And just how we played with all this stuff and kind of figured out, when something going to slide down the piece of wood or the plank, or would slide down the hillside. So I'll try to explain that a little bit better. It's not going to be part of the test, you guys, all this cosine math stuff. But when you understand it, it's actually pretty cool. Okay, so you got to have a slope. Otherwise, gravity's not going to be working on it. All right, so what's going to make your mass wasting event worse? If you have a steep slope angle. So, you have a vertical cliff behind your house, not a very good thing. But if it's a 2-foot tall vertical cliff, it's a heck of a lot better than if you have, a 100-foot tall vertical cliff. That's what relief is. It's the vertical elevation difference. Okay, and remember, if you've got that 100-foot cliff, if stuff starts breaking at the top, moves down, it's going to be going fast enough to wipe your house out. If the cliff collapses and it's only a foot high, it might damage your house a little bit, but you'll probably live to tell the tale. All right, water. Water and ice can act both as a lubricant and as weight. Water weighs 8 pounds per gallon. That's actually pretty heavy. Roofs collapse because of the weight of water and the weight of ice and snow on them, and it can also cause that same stress for rocks. Now, we've all slipped and slid in both water and ice. You know how that feels, and so water and ice can both act as lubricants and make mass wasting worse. All right, the amount of loose rock. If you have a hillside that's, solid rock and there's not really anything loose on it, maybe you won't have as much, small scale mass wasting. There's still some other dangers that could happen. But the more loose stuff you have along the sides, the more likely it's going to be coming downhill at some point in the near future. All right, this is kind of cool, you guys. It looks all hard and scientific. Remember going to the beach as a kid. You got your sand buckets, your buckets, and you want to make sand castles. And you fill it full of dry sand, and you flip your bucket over, and you've got, kind of looks like a volcano. You've got this pointy thing that's not stuck together. And you're like, wow, that's not the sand castle I was imagining. When sediments are completely dry, they don't stick together, and mass wasting is more likely to occur. Now, let's say we have a light rain, or you move down on the beach and you get into the slightly damp sand. You pack your bucket full, you stick it up, turn it over, and out comes, this perfect bucket-shaped building. And so the lesson here is a little bit of water is good. On the left-hand side, you've got what it looks like with the sediments and a little bit of water. Water is actually very sticky. It has to do with some of those special properties of water we'll be talking about later. And so a little bit of water makes those sediment grains stick together, as you can tell when you dump out your bucket and the sides are at 90 degrees. You still have those vertical sides of the bucket because the sand is sticking together. Now, when the soil is saturated, then your chance of mass wasting increases. This would be like going to the beach and filling your bucket up with soaking wet sand from the surf zone. You flip over your bucket and it looks like a cow pie. Okay, not very pleasant, right? You don't make a cool, sandcastle with 90-degree walls when you do that. And you can see on the right-hand side that this is what the soil looks like when it's saturated, or what sand grains would look like when they're saturated. And water now is not sticky. In fact, it's worse than that. It forces the grains apart. And so the lesson here is completely dry is not good, saturated is not good, but when it rains just a little bit and the ground's able to handle it, it's actually a good thing. It makes the sediments stick together better. All right, now this diagram looks scary, but it's not. Let's look on the left-hand side. Increasing rate of movement. So on the bottom left-hand side, it's slow, and at the top, it's fast. All right, and then on the bottom here it says increasing water content. And so we're going to go from dry, and remember, some mass wasting can happen with no water, moist, and then saturated. Okay, so what we're going to talk about is, we're not going to talk about all of these. We're going to talk about some of these different mass wasting events. And the ones that happen slowly are much more common, and they're also much more costly in yearly fixing money. You have to spend a lot of money every year to fix these things, even though they're happening slowly. But they tend not to kill people. Now, the events that happen very fast don't happen quite as often, but they're deadly because you can't get out of their way. Okay, so they cost more in the terms of life. All right, we're going to talk about debris flows, and there's actually 3 different types of debris flows. There's earth flows, which are slow, there's mud flows, which are faster, and then there's something called a debris avalanche, which is really fast. And, they're flowing. You name these things, it's what's moving and how it moves. It's loose material or debris, and it's flowing. It's behaving like a fluid. But remember, you've got a thick milkshake, you've got a thin milkshake, and you've got some water. Those are all fluids, and they'll move like fluids, but the thick milkshake moves very differently from the thin milkshake, which moves very differently from the water. So the earth flow will be kind of like the thickest milkshake. The mud flow will be kind of like the thin milkshake, and then the debris avalanche is very saturated, very fluid, and that would be kind of my analogy of the water. Now, depending on the hillside, and how saturated this is, they can move up to 200 miles an hour. You can see why they can kill people. And in fact, I've included the video footage from La Conchita debris flow or debris avalanche. that ended up killing 10 people. And you can see how fast it is. It looks like chocolate milk, but it hits like a freight train. And if you're in the way of that, you have no chance of getting out. The best thing is that if you live next to a very steep hillside and it's raining really hard, go visit somebody else who lives someplace safer until the danger is past. All right, and so we have water involved in these, again, different amounts of water, and they loosen up the loose material and make it non-cohesive. It doesn't stick together, and they'll move downstream. Got a great picture of a mud flow in there too. It's in Devore, California, near San Bernardino, and you can see a couple of boulders just floating on by, and those boulders are the sizes of cars. Okay, so it's thick, it hits like a freight train, not like water. All right, so the slowest, again, earth flow. Next is mud flows. And we've talked about one type of mud flow, that volcanic mud flow. But there's also non-volcanic mud flows, okay? And then the debris avalanche, which is the most rapid. So these are going to occur when you have heavy rainfall. We've been having a lot of that lately, and even some snow melt, because some of that rain that's been coming in lately is warm. And you've got loose material. It's going to mud down slope, and it's very destructive. Okay, it's very common in areas that don't have a lot of vegetation, like our areas after fires. Mud flows are very, very common. And in fact, that Devore up in San Bernardino County mud flow happened after heavy rains, but the summer before, that area had been burned out by a big wildfire. Okay, and also, if we have intense rainfall that we're not really expecting, like an El Nino year, or we get the Pineapple Express. All right, now I didn't see this happen, but I can see how fluid it is. So this is either a mud flow or a debris avalanche, and that house is built in a really stupid place. There's no vegetation on that hillside to hold it in. Maybe there was a fire and it killed, it took out all the vegetation. But that house was very lucky. In fact, there may be some houses underneath that mud flow which weren't so lucky because it moved very fluidly. You can kind of tell that by how far it moved and the lobes that it formed. And so, don't build your house like that, or don't buy a house that, is at the base of a steep hillside that is got a lot of relief and it's got, loose material along the sides and no vegetation holding it in. We call that temporary housing. And it doesn't matter if that house cost $1 million, it's temporary because Mother Nature is going to wipe you out. All right, earth flows, this is the slower flow. It's going to move very thick material, and these typically happen on steep hillsides, again, loose material with heavy rains, and it can be triggered by humans. If the people at the top of the hill are overwatering, their pool's leaking, their septic system is leaking, or even if the people at the bottom of the hill cut into the slope to maybe give themselves some privacy or some more backyard, so that humans can cause this. I call it stupid human tricks. But these move very slowly, and they typically don't kill people. They do cause a lot of damage. Okay, and so here's an earth flow. Now you guys see in the back of that, you can see something that looks like a horseshoe. We call it a scarp, that little scar that's like a kind of a horseshoe shape. If you go out on Highway 80 out towards like Vacaville and past Vacaville and Fairfield, you start getting into kind of what I call cow country, some hilly areas that have a lot of cows. And when I go drive through there, I always see these. There's lots of earth flows and mud flows happening out there. Okay, but boy, the earth flows, and you can see that scarp or that scar in the back, and it's usually horseshoe shaped. And you can see the lumpy, bumpy topography. If you've got lumpy, bumpy topography near a house or something, don't buy that house. If you have 1,000 acres and it's out, far from your house and other structures, and your cows just have to walk over it, then don't worry about it because, it goes so slow, even the cows can avoid it. All right, and here's another look at an earth flow. Again, look at that scar in the back, and then look at the lumpy, bumpy topography. And here's just taking out a fence, but if your house was in the way, it would take out your house. All right, now this is up in Santa Ynez, which is in northern Santa Barbara County, and you can see there's a cow, and the cows are fine. It's out in the cow country, and you can see the scar, and then you can see the earth flow that slowly moved out. No cows were harmed. Now, this is a big one. La Conchita is just to the southeast of Santa Barbara. It's just into Ventura County along Highway 101. And there's a very steep hillside with loose material. It's been mass wasting for many thousands of years. And this was an earth flow that happened in 1995. You know, if you live in Southern California and there is very heavy rain, typically Southern California, in places where I've lived, we get between 8 and 10 inches of rain a year. That's our average rainfall. In Rockland, it's 35 inches, and up in Auburn, where I live, it's 45 inches a year average rainfall. So if sometimes we have 30 inches of rain come in, maybe on an El Nino year or more, rain could even fall. I promise you, there's going to be some mass wasting. Now, luckily, this event was a slow one. It was an earth flow. Okay, and if you look in that back row of houses, there used to be houses there. And people were in those houses, and the houses start to shake and creak and crack and stuff, and the people ran outside and said, hey, what's happening? And the houses got plowed over, but nobody died. Okay, well, unfortunately, that made the people confident that 10 years later, it's not going to come as an earth flow. 10 years later, after heavy rains, it's going to become a debris avalanche. And I have a movie, and 10 people were killed because it didn't just stay in those back houses. It came far out towards the front of the picture. So kind of bad news. So you guys, you don't want to live in a place like this. This is crazy. All right, so mud flows, they're more wet than those earth flows. They're faster, they're more dangerous, they do kill people. We have seen the volcanic mud flows where volcanic ash is part of the matrix of the mud flow. And remember that it could be happening at the time that the eruption happens. You'll have a hot steaming mess, but it can also happen, a year or more afterwards, because until that loose volcanic ash on the side of a volcano is glued down or removed, it's potentially very dangerous. Now, in the deserts of the Southwest, a lot of times you will get non-volcanic mud flows, so flash flood type things. I've got some great footage from Devore. It's out in San Bernardino County. And what happened there was that they had during the summer before, a very bad wildfire, and it denuded all the hillsides. And then in came amazing amounts of rain, and it caused mud flows. So be sure to watch that video. It's pretty amazing. And you'll see big boulders, the size of a car, just go floating on by. All right, now after Mount St. Helens erupted, this is a lahar, or volcanic mud flow, and this was a several 100-foot deep river valley. This is the Toutle River. Now, you guys, you're probably familiar with the Forest Hill Bridge. Now imagine that bridge being wiped out and that entire canyon being filled pretty much to at least bridge height with steaming hot mess. And that's what could happen, not there because we don't have great volcanoes, but it's similar to that, and that's what happened in the Toutle River. All right, remember that we do have our own local lahar. Luckily, we're not in any danger now, but 5 to 19 million years ago, our area was inundated by lahar after lahar after lahar, and the ridges that surround the Rockland campus are made up of this material, so you've probably seen it. It's on either side of Sierra College Boulevard from school. You can see it in the outcrops when you go up the hill. All right, now this is a flash flood in the desert. Now when I take students out in the desert during the summer, they don't want to sleep up on the sides there because there's sharp rocks and cactus and prickly bushes and things like that. They always want to sleep in the wash, and I say no. And sometimes we get kind of heated discussions about why I'm not letting them sleep in the nice soft sand. And that's because, within the rain, if any rain happens within that drainage basin, it may have no rain fall where you are, but you can get a flash flood. And if students were camping here in the middle of the night and this came through, it would have killed them. So this is a non-volcanic flash flood or mud flow. All right, now make sure you see the video of the debris avalanche at La Conchita. This happened in 2005 and it killed 10 people. It happened in an overlapping area to the 2004 earth flow, or actually 1994 earth flow, I'm sorry. People got complacent. They didn't know it wasn't a big deal last time, but you don't know how it would be. I knew it was going to mass waste. It could have just been an earth flow, but unfortunately it was the worst case scenario, and 10 people died, including 3 children. That's unforgivable. There was an evacuation notice, but people ignored it, and nobody came and dragged them out of their houses, and 10 people are dead because of it. So this is You know, look at it. It looks like chocolate milk, but remember, it hits like a freight train, and 10 people died. It was, 30 feet thick, and it went out really far. In fact, it closed Highway 101 for over a week. All right, so here's an aerial view of the aftermath. You can see Highway 101. It's all been cleaned up, but look how much farther. The earth flow 10 years earlier had just taken out that back wall of houses, but this lobe of this very wet fluid stuff that hits like a freight train came quite far out. So again, you guys, be aware of what you're buying if you're where you live. All right, we're going to talk about true slides, and I realize that I'm going to have to actually do a little movie for you so I can actually draw these. Now, there are two types of true landslides. One of them is called a block glide or a translational slide, and the other one is called a slump or a rotational slide. Now, the hillsides that I grew up in Santa Barbara, are tilted sedimentary rocks, and the cliffs right by the ocean, you can see the layered rock. It's tilted, and the rock breaks along the bedding plane between the sedimentary layers, and it slides parallel to those bedding planes, which is parallel to the surface, and that's called a block glide. Okay, the other type happens, and you can see slumps happening out, again, along that same area out on Highway 80 past Vacaville and Fairfield. When you get into the hills before you get out to the coast, the cow country as I call it, you can see slumps happening. And there is no parallel to the surface break. In fact, the break is like, it's a curve, it's arcuate. And my analogy for this is a lazy boy recliner, head down, feet out. Okay, and we'll take a look at that. All right, on the left-hand side, we have the block glide, like what I have where I grew up, and you can see that the break surface is parallel to the surface of the earth, and that's usually defined by a bedding plane. Okay, now on the right-hand side, we have a slump. And remember the lazy boy, head down, feet out? That's what happens. So it stays pretty cohesive, and it breaks in that curved or arcuate matter. It just does this little rotational thing. And you do end up with that scarp, like what we talked with the earth flow too. But this is acted solid and not as kind of a thick fluid. It's just rotated out from under itself. All right, these are my cliffs that I grew up in Santa Barbara, and these are thinly bedded, tilted sedimentary rocks. And, boy, every day I used to go down there, there was a new rock slide, and it was a block glide type. And the break, you get undercut the cliff, and then it's unsupported, and it just breaks along the bedding planes and slides right on down. All right, here's some good shots of some slumps, and they've rotated out, and you can see that, again, that kind of arcuate break in the back, and they do not have clear bedding planes, and they definitely have not broken parallel to any bedding plane. So these are slumps or rotational slides. All right, rock falls. Boy, they've actually made the news recently because Yosemite has had a few. Be really careful, you guys. Don't hang out under those 1,000-foot cliffs. Don't set up your tent there or something because you're asking for it. Yosemite's pretty safe. You just don't want to spend too much time in under those very vertical cliffs. And this, you don't need any water whatsoever. And what can fall is anything from dust silt clay to, house size, boulders and stuff. So you got to be really careful. They typically just fall at the base of the cliff, but if enough material falls, it will create what's called a rock avalanche, and it will move out from the base of the cliff. Okay, this is the aftermath of a very famous, very large rock avalanche that happened in Yosemite in 1996, and it's really a miracle only one person died. Now, the one person was not hit by rocks. They were actually, when this amount of material falls down, a wave of air is pushed in front of it, and it knocked over a tree that hit the person and killed them. But it was traveling so fast, you couldn't run out of its way, and look at the amount of tonnage that fell down. This is pretty serious. All right, and actually a guy was climbing Half Dome and heard it, turned around and got a picture. That's that really big 1996 rock avalanche, and you can see it not only went to the bottom, it moved out, knocked over a tree that did end up killing somebody. But July and Yosemite, it's so crowded, and so it's really a miracle only one person died. All right, creep. Creep is the slowest form of mass wasting, and it just everywhere. It's all over California. You know, when the weather changes around here, I always think about creep because creep is a downslope movement very slowly of loose material. And you look at that, and if you tried to sit outside and watch creep, you'd be really bored because it could be like a 1 millimeter or 1 centimeter a year. It's pretty slow, but it's very, very costly because it's so widespread. Now, it is dependent on the soil. Clay soil, or makes it worse. Steeper slopes make it worse. If you got a lot of rain or a freezing type climate, it makes it worse. A lot of soil moisture makes it worse. We're just going to learn kind of the basics of it. All right, what do you need? You need the soil to expand and contract regularly. And think about things that make the soil expand. When the soil freezes, it expands. When the soil gets hot, it expands. And when the soil gets wet, it expands. All right, what makes the soil contract? When it thaws, when it dries, and when it cools down. And so think about it. I live up in Auburn. It's like we're either going through a freeze-thaw, a wet-dry, and a hot-cold cycle. It seems like every day it's one or the other. And so, yeah, if you have a hillside here in Auburn, it's probably creeping. So you do have to have a little bit of moisture, but it doesn't have to be saturated. If it's saturated, you'll probably have like, an earth flow or a mud flow or something like that. And again, it's slow downslope movement. And I'll kind of show you guys the physics of it. And we'll also look at, I'm sure you've seen it. Now, the cartoon on the left, you've probably seen, tilted over power lines or fences. And you've been like, what fool put those in? Well, they were originally vertical. It's just that that top layer of soil is slowly moving up, up and down, and going downhill. And a lot of times you'll see, falling over grave markers or a tree that has that big bend in it. Now, snow can make trees have big bends in them like that, but, in Santa Barbara, our trees do that and we have no snow. And so, it doesn't have to be the snow. So try and think about the other things that could happen. Now on the right hand side we have the real example, and even though you can't really tell which way is downhill is to the right, and I can tell by the bend. Look on the left cartoon, downhill is to the left, and you can tell that by the bend. You can tell it from the picture itself. But look at the way that those tilted sediments, when the soils form in that top layer, and you can see that little cartoon at top where it says expand, contract. The sediment will expand perpendicular up from the surface, but when it contracts, it gets pulled down to the center of the earth because of gravity. And so check it out. It's slowly, through the freeze-thaw, wet, dry, hot, cold cycle, will expand, contract, and inch its way down the hill. All right, couple examples. I love the drunken trees. They're not drunken, but it's pretty funny. You see the big bend in the tree, and that again, the tree has the growing part of the tree actually is geotrophic. It wants to grow straight up, and so it'll always be kind of correcting and growing straight up. But the base is fixed, and it's fixed in the soil that's creeping downhill. Here on the right-hand side, you can see fences that are way bent over, and that's because of creep on the hillside. Yes, this would affect your house, so this would not be a very good place to build. You'd really have to spend a lot of money on your foundation and sink pilings, I don't know, 100 feet or more deep to try to counteract this. So it's just kind of easier not to do it, not to build on it. All right, and so again, soil expands, it moves up perpendicular to the Earth's surface, and then when it contracts, it pulls down towards the center of the Earth due to gravity. And over time, you can just watch that little pebble there creep on down the hill. All right, so what can you do to prevent it? You can. If you do, let's say you inherit your grandfather's farm or something, and you're like, uh-oh, here's some of the signs that Holly told me. There's a couple things you can do. You can actually, if you're building a house, make sure you don't build it in a bad place, but also make sure you don't cause the problem. And I'll show you guys the slide in the next slide that you don't want to oversteepen the hillside. Okay, in fact, you have to have a permit to grade. You can move stuff around on top of the hillside, but if you cut into any hillside, legally you have to have a permit. It's there for your safety and your neighbor's safety. Never undercut the slope, you guys. That's just lame. You're taking away all the support of the slope, and it's going to pay you back big time. All right, retaining walls are, again, something that is permitted. You have to have a permit because you can waste a lot of money on a retaining wall that doesn't work versus putting in the proper pipes and drainage, and then your retaining wall may actually work. But you know what? If you have a big problem, even the most expensive, well-designed retaining wall is a Band-Aid. Pretty soon it's going to fail. Now, drainage pipes. As a kid, I saw those drainage pipes with holes in them. I go, what idiot would buy a pipe with holes? I buy it all the time. It's called perf pipe, perforated pipe, and it actually is great for draining areas. You got to know about proper terracing. It's kind of weird, you guys. Ancient Asian people and the Mayan people in Central America were fabulous, physicists in a way. They figured out terracing, and their terraces, 1,000 years later, are still workable and looking great. But some idiot around here will terrace their hillside, and again, something that is legally permitted. You have to be, they're just trying to protect you. And you do it wrong, and then boom, you got a mass wasting event that takes out your house. Okay, you got to know the geology of the regions. I showed you those cliffs of Santa Barbara, the bedding plains or zones of weakness. And I would not buy a house on the cliffs of Santa Barbara. Those cliffs are coming down at a pretty rapid rate, 1 to 2 feet per year. So you don't want to buy on lumpy, bumpy topography. It's just going to happen again. You don't want to buy at the base of La Conchita. I promise you, in your lifetime, it's going to happen again. All right, and the other thing I wanted to share with you is some of the highway road cut steel cables, nets, other barriers, and those are always good ideas. When I was a kid, it used to bug me because I want to see the rocks, and now it doesn't. It makes me very grateful because those nets and cables and fences and stuff catch big boulders that would kill us maybe. All right, so just a couple of these barriers along the highways. The top left one has a cage over it, kind of a netting. Bottom left has a steel fence, and I've seen huge boulders caught in those steel fences. And on the right, we also have a steel-type fence that would catch anything that would come out of that hillside. So it's actually a good thing, even though it's not always the most attractive. All right, here's kind of what not to do. You have a hillside on the left, and the trees are going to have that bent trunk on there. Now, what these people have done is they've oversteepened the hillside. They've stripped off all of the vegetation. They've added fill, which is really not good. Swimming pools, sprinklers, a septic system. This is just asking for it. They've undercut the cliff. That is just going to be mass wasting central. You don't want to do that. Okay, so be very, very careful. All right, on the left I have an improper retaining wall. It's just waste of money. And on the right, every certain number of feet you have to have that perf pipe, because on the left the water pressure just builds up and pushes it over. But on the right, the water, because of its pressure, will find the void, which is the pipe, and will fill in there, and that's a much better thing. And so you can see the water running out on the sidewalk, but it's not pushing the hill down. All right, on the bottom left, what we have is the way actually a lot of our highways are built in California, because we have a lot of layered sedimentary rock that's tilted. Now, it's kind of hard, you guys. Those lines, those stripy lines, are the bedding planes, and all the stripy lines that are pointing kind of towards the right, above the right-hand side highway, are going to fall into the highway eventually. And so what they've done on the right-hand side now is they've removed all of those layers that would have slid right onto the highway. I don't know why they removed the left-hand side. Maybe it's a similar thing. That's not really logical to this, but the right-hand side, they've done that. Now, they've done that on the highway that I take between Highway 5 and Paso Robles to get out to the coast so I can go home to Santa Barbara. And they've actually removed all that top burden, and now they're trying to get the vegetation to grow and to hold in what hillside is left. All right, now here's a winery up in Northern California, or Northern Santa Barbara County. It's not Northern California. And when they put this in, they put a lot of money in, and I'm kind of just walking my dog by there, and it's like, hey, did you get that permitted? It doesn't look safe. And this is 1 day worth of rain. Probably did $100,000 worth of damage. So they did hire a geotechnical firm, and they did get this fixed, and now it's not a problem. But improper grading, you guys, you gotta be very careful about that, because it's just gonna, if you have to fix something and it costs $100,000 or more to do, you've just wasted a huge amount of money. You could have done it right in the first place. All right, this is actually kind of cool. This is a cool place to go hiking near Santa Barbara. It's called Montecito. It's where Oprah Winfrey lives. And in fact, right around the corner, Steve Martin lives. But don't worry about Steve Martin. There's another way out. Pretty much every time it rains heavily, this cliff right here, the slope, mass waste down, kind of in, can be kind of a muddy flow, but it can also be that block glide type thing because of the tilted sedimentary layers, and it blocks the road for a while, and then they clean it up and they put back in that little Band-Aid barrier. But this is just something that happens every single winter. It happened this winter already, and it'll probably happen again if we get much more rain down in Southern California. All right, this is the Cuesta grade. If you end up at San Luis Obispo, Cal Poly San Luis Obispo, you guys are going to know this. You come out of the coastal plain, you got to go up the hill, and then this is how you can kind of get to the place where you could catch the highway over to get to Highway 5 to get back to the Sacramento area. They were working on this for 20 years, and I thought this was kind of clever in that they used some railway cars. And I couldn't, you can see it's not very safe. I am the passenger, I'm not driving, and I couldn't quite, hang out and get the picture, but there were some huge boulders behind those railway cars, so they had done their job while they were trying to stabilize the hillside, and they'd caught the rocks that could have gone on onto the highway and killed people. So, ugly but good. Here again is another shot from the beach where I grew up, and you can see the thinly layered beds. And what people have done is they put down waterproof kind of cloth. It's kind of like that weed cloth that you can buy at Home Depot, and they try to collect all the water and send it down these pipes. And boy, when it's raining and that water shooting out of that pipe, it's very interesting, because if the water just seeps down, it'll weaken those bedding planes and make your mass wasting much worse. And a couple of houses are just barely hanging on. Okay, this house has actually been condemned. People still go down there a little bit, but they can't live in there. They don't have parties in there anymore. And you can see one of the pilings on the far right hand side is hanging off. And when I was a kid, they had a yard. Okay, this cliff has been eroding back at about a foot a year, and they've tried to stabilize it. They've got bad plants growing over the side. They don't need that plant. You can see they've sprayed a little bit of quickcrete, which is actually illegal, but we don't call and report people. It's a Band-Aid. I fully expect if I live a normal lifetime that this house will fall in, and I'll get pictures for you. All right, now, closer to home, since I've lived up in this area, Highway 80 was closed for a day because of mass wasting events. And in 1997, before my time up here, Highway 50 was closed for a while because of mass wasting events. In fact, when I go up Highway 50, it kind of gives me the creeps. I love Highway 50, it's beautiful, but I'll only go up there in pretty perfect weather. You couldn't pay me to go up there in a heavy rainstorm because it's just dangerous. And, all the lumpy, bumpy topography creeps me out, and it's gonna come down again. So be a little careful. If you inherit a cabin up there, just pick your times that you go up there. But I really wouldn't buy one up there. Okay, it's a great place to visit in perfect weather, but stay out of there in rainstorms and when the snow melts because it's dangerous.